Good evening to all. Today we are going to present the vulnerabilities and the recommendations for the application Simple SAML PHP. Today, me and Yazin we are going to display the vulnerabilities and the recommendations for the SAML PHP. The single sign-on is an authentication method that enables users to securely authenticate with multiple applications and websites by using just one set of credentials. Let's move on to the introduction. The application choose for this project is called Simple SAML PHP. It is the well-known application that handles authentication and was created in native PHP. Unit, a state-owned corporation in charge of maintaining Norway's national research and education network, is in charge of this project. This open source PHP authentication tool supports SAML 2.0 as a service provider or identified provider, and it is written in PHP. Single sign-on for the web is frequently implemented using SAML, that means Security Assertion Markup Language, before allowing access to resources. Simple SAML PHP connects to an authentication source and authenticates users against the source. As a team members, we have discovered multiple security flaws in the application. After reviewing the issues page on GitHub and using SonarCloud, we run the application. Let's move on to the vulnerabilities which we identified. One is brute force password guessing vulnerability in admin-based logins. Second one is session fixation attack. Third one is weak pseudonym number generator used in functional codes. Fourth one, weak cryptographic hashing algorithm used in functional codes. The fifth one is timing attack vulnerability. Let's move on to the brute force password guessing vulnerability in admin-based login. A security flaw known as the brute force password guessing vulnerability can exist in logins where an administrator must provide username password to access a system application. It happens when an attacker uses numerous character combinations to repeatedly guess the right password until they succeed. The reason this approach is known as brute force is because the attacker literally tries every possible combination until they find the right one. This program allows an unlimited number of login attempts for the admin login. This is primarily due to the lack of way to stop brute force password guessing in the login class and other implementation class. This is the affected source which we have displayed here. And let's move on to the recommendation. To address this problem, a cap is placed on the number of authentication atoms linked to a single active session cookie. The goal is to set a limit on how many times a session ID can be used to log in before blocking that session ID. Therefore, access to the application will be denied if its condition is broken. The implementation. We have started session using session underscore start with a bracket. Because we are utilizing session, it is set to 0 if session wrong atom count is not provided. User cannot log in if password is incorrect or wrong atom greater than or less than number 5. The wrong atom count is increased if the password is incorrect. Upon a successful password entry, the wrong atom count is reset to 0. This is the implementation which we have provided here. Let's move on to the second one. It is session fixation attack. That means there is no secure way of generating session ID during admin logins. An attacker can hijack the session by predicting the session ID or intercepting it. We have provided the affected file and the affected resources here. This is the affected file and this is the affected resource. And let's move on to the implementation. A unique session key with the prefix generated for the user. The session underscore start double records is called inside the constructor to ensure that the session is started secure. So we have provided the implementation here. My colleague will continue with the rest part.
Thank you, Tabitha. And we will continue with the third vulnerability here. So in here, I'm gonna talk about weak pseudocode, pseudo random number generator used in the functional codes. In here, in this code, a weak pseudo random number generator, a sort of algorithm that is produced what looks to be random series of integer, but it actually deterministic and can be predicted by or replicated by someone who is aware of the process and its seed value. A weak pseudo random number generator generates are frequently used in programming languages. Uh, this is a beneficial for stimulations, video games, and users where some degree of unpredictable behavior is desirable. Next slide. These are some compromised files which have the weak pseudo random number generated used in the functional codes. And here you can see the rand function is used in this code. So we need to identify the impact. It may possible that for an attacker to predict the next value that will be generated using this algorithm rand method. So let's move on to the next slide. So the recommendation will be instead of using rand, uh, we can use rand int or rand bytes. That is more secured algorithms like OpenSSL random pseudo bytes that can rely on cryptographically secured random number generator. So verify and supply the crypto and strong argument if OpenSSL random pseudo byte function is being utilized. Utilize the random numbers only once. Verify the database or file security. So the implementation will be instead of using rand function, we can use cryptographically secured algorithms like random int or OpenSSL random pseudobytes. So let's move on to next part. So here you can see the implementation. The rand function is replaced by the rand int function. Next slide, please. So the next vulnerability will be weak cryptographic hashing algorithms used in functional code. Uh, the hash functions used in the data storage handler PHP are not implemented correctly. So the functional codes are typically weak typically weak cryptographic algorithms like SHA algorithm and some of those algorithms. Let's move on to the next slide, please. So these are the affected files which contains the weak cryptographic algorithms which encrypts the data. So by using weak cryptographic algorithms, it is a hacker can quickly assessing it by guessing a random public key or something like that. So the recommendation is it is advised to use the more secured algorithms. So the official PHP function and password hash, password verify, and password needs to be rehashed, encouraged to be used in sensitive data. It is also recommended to rehash the data regularly since hashing algorithms become more less secure over time. So let's move to implementation. Cryptographically safe SHA-256 hash algorithm replaces with SHA-1. So the previously used algorithm was SHA-1. So we are replacing it with the more secured algorithm called SHA-256. So, so the next vulnerability and the final vulnerability we have discovered in this code is timing attack vulnerability. In this current implementation, the crypto PW verify function is used to compare the user provided password with the stored password hash. If the password is incorrect, the function will return a false and login attempt will fail. An attacker can use this timing information to determine if if their guessed password is closer or farther than the actual password. Let's move to the next slide. So here you can see the password verify function is used in the affected file. So our recommended our implementation to fix this vulnerability, instead of password function, we are using the hash equals function uh, instead of crypto password verifier, because the hash equal function takes a constant amount of time to execute, and regardless of contents and compared strings, it cannot be used to determine the length of contents or the actual password. So here you can see the implementation of the new function, and we have uploaded the uh, vulnerabilities fixed code in our GitHub repository also. You can refer the link by using the our GitHub repository. That's all. Thank you for the for your time.